Let's discuss geometric series. Uh, Let me start with the geometric sequence. 2, 6, 18, 54, and dot dot. And let me turn this one into a series. 2 plus 6 plus 18 plus 54 dot 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 54 plus. And in here we can talk about two things. One is sum, other one is the partial sum. So we are going to talk about partial sum, and the sum we will discuss later. The partial sum is the addition of uh, some terms from first. The sum means the addition of whole terms. If I write partial sum of two terms, that's mean usually we use S sum uh, to show the partial sum, and T1 plus T2. First term and second term, that's the meaning of that. The first term is 2 and the second term is 6. So the partial sum of two terms is 8. 2 plus 6 is 8. So S3 is for first term, second term, and third term. That is 2 plus 6 plus 18. 18 plus 2, 20, and then 26. So this is the idea behind in partial sum. So if it is SR, so T1 plus T2 plus 3 plus dot 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 up to R terms, addition of R terms. Um, Now if I ask a question about how to find S10, then you know that up to T1 plus T2 up to T10. You have to add 10 terms. So, but we don't know the other terms. So we'll work out differently. We know that S3, partial sum of three terms, is T1 plus T2 plus T3. That is 2 plus 6 plus 18, that is 26. So we'll find this 26 differently, first of all, in a different method. What I'm going to do, I'll write S3, that is 2 plus 6 plus 18. So this is first. I'll name this one as first, and I'll multiply this term, this equation, by the common ratio. What is the common ratio? R is 6 divided by 2, that is 3. So I will write on top 1 multiply by common ratio, that is 3. So this is going to be 3s1, 3s3, this is s3, and then this is 3 times 2 plus 6 plus 18. So 3 times 2, 6. 3 times 2, 6. 3 times 6, 18. And 3 times 18, 54. So I'll take this one as 2. Now I multiply the first term, first equation by 3. Then I will minus this one. 2 minus 1, that is 3s3 minus s3 equal um, 6 plus 18 plus 54, that is the second equation right side, minus 2 plus 6 plus 18. Now we can see that this is become 2s3, and this is cancel out, plus 18 when you multiply this is 18 cancel out, and okay, I will write 618 plus 54 minus 2 minus 6 minus 18 cancel out, minus 6 cancel out, so remain is 54 minus 2, that is 2s3, and s3 is 54 minus 2 52, and divide by 2, that is 26. So we simply add these three terms and we found out that is 26. And the second method we use, we know that these three terms, instead of adding, we multiply by 3, the common ratio, and then we minus those two equations, and we found out S3 is 26. Now my next question is, how do you find S10? Now let's see how did we do this. How did you S3? How did we work out S3? So S3 mean 54 mean, right? 1, 2, 3, 4, fourth term, minus 2 mean first term, and the common ratio r minus 1, that is 3 minus 1. Likewise, we can now let's see the relationship. If this is 3, that is 4, 1 more than 3, and this is as normal everything. Now if I need to find S10, this is going to be t minus t over which t this is going to be. If this is 3, this is 4, this is 10, this is 11, and this is as usual term 1, and this is 3 minus 1, which is r minus 1. Let's what is t11 now? T1 we know actually. T1 is 2. This is 3 minus 1, 2. Now T11 is the issue. So instead of now writing like this, in terms of T, we will turn this is to a different way. So T4 I can write, fourth term we know we can write AR3. And first term we know that is usually A. This is AR. And this is R minus 1. So same way you can write T11, you can write AR10, and this is first term A and R minus 1. Now if I simplify a little bit, okay, now you can find instead of using this one from this formula, you know what is A. Okay, let me simplify actually. So I can take A out here. This is R3 minus R1 or R minus 1. In here, if I take A out, R10 minus 1 over R minus 1. So likewise, I can simplify here. I can find now S10. What is S10? A we know that is 2, and R we know that now 3, 3 to the power 10 minus 1, 3 minus 1. So now we can work out this one. This is going to be, I can see, 59048 from the book. If I ask how can we find S20, then we know that T21 minus T1 over R minus 1. Or we know T21 mean AR 20 minus A over R minus 1. That is A R20 over R20 minus 1 over R minus 1. Another one. Now this is S20. Now you can forget about this part now in the middle. Now S20 if you want. So you need A, then R20, the same value, and the common ratio. Let's write S100. Then we need A R100 minus 1 over R minus 1. Same way, if you need to find Sn, you can do that. A n terms. This is 100 terms. Rn minus 1 over R minus 1. If I work out a little bit further, from here, I'm going to take minus 1 from up and down, numerator and denominator. So minus A, this is become minus Rn plus 1, and this is become minus R1 minus R plus 1. So minus to minus cancel out. So Sn is minus Rn plus 1 over minus R plus 1. So you can write like this one, like this. Sn equal, this is positive. So 1 minus Rn, A is missing here, and A times 1 minus R. So the conclusion is, this is, either you can write this one. Let me write again. Sn equal Arn minus 1 over R minus 1, or this is also right. Sn equal 1 minus Rn over 1 minus R. Usually we use this is R greater than 1, this is R less than 1. And now we work out this equation with the standard notation. A plus AR, actually this is example 12. AR square, AR cube plus dot dot, and AR n minus 2, AR n minus 1, ARn, ARn plus 1 plus dot dot. Now I'm going to find the partial sum of n terms. It means I don't need everything. Going to be AR up to n minus 1, A plus AR cube plus AR n minus 1. So this is going to be first equation. Like last time, so we have to multiply this equation by the common ratio, that is R. Then this is going to be Rsn. So then r times a. This is become ar square, ar cube, and this is become arn. Now, if I write this one more term before that, arn minus 2. So arn minus 2 multiplied by r, this will become arn minus 1. So this is the second equation. Now 2 minus 1, equation 2, from 2 subtracting 1. Now you can see that this is rsn minus sn equal, these all terms are going to cancel out, and remaining is this one and this one. So this is positive arn, and since we are subtracting here, this value is going to be negative a. Now we factorize r minus 1 and factorize here rn minus 1 and divide by r minus 1, both side r minus 1, and we can take minus 1 out from the numerator and denominator. So this is plus rn become negative rn, minus 1 become plus, and when I take negative out from the denominator, this plus r become negative and negative become plus. So negative cancel out. A minus rn plus 1 over minus r plus 1. So that is a times 1 minus rn. This is 1 minus r. So basically these both are right. So either this one or this one. Both are correct. And when r greater than 1, we usually use this one, and r less than 1, we usually use this equation. Let's discuss example 13. Actually, part A we have already discussed. 2 plus 6 plus 8 plus 54. So we want to find the 14th term. Basically, we need to find S10. Sn, we know that a r minus 1, r minus 1. If this is n, this is n. And the first term a is 2, r is 6 divided by 2, 3. So we work out actually. So 3 to the power n equal 10. So S10 equal 310 minus 1 over 3 minus 1. And 310 minus 1 over 2. We can see this answer is 59048. Now let's discuss part B. 1024 plus minus 512 plus 256 minus 128 plus plus 1. So we need to find the addition of these terms. This is first term, second term, third term, fourth term, and let's say this is nth term. So we need to find the nth value to apply the equation Sn equal arn minus 1 r minus 1. Now we know that A equal 1024 and R is minus half, um, because minus 512 divided by 1024. So this is minus half. So Sn equal 1024 uh, minus half, and actually we have to use the it doesn't matter which equation, the other one is easy. 1 minus Rn. This is going to be 1 minus half n over 1 minus half. The problem is n we don't know. Now we have to find n. So nth term we know that is 1, and nth term we can write ARn minus 1. So A we know that that is 1024, R is minus half, n minus 1. Now we know that from 1 and 2, um, 1024 minus half n minus 1 equal 1. 1024. I can see now the ratio is negative. Now we have to give, so I know this value is fixed, that 1 is in on the system, on the sequence. So I need to give an argument to come out of this negative value. So this is my argument, because we are going to use log as usual. I can write minus 1 to the power n, 2 to the power, sorry, n minus 1, this one equal 1. Minus 1 to the power n minus 1, 2 to the power n minus 1. If you write in the middle, so just bring into up. And then cross multiply. 1024 minus 1 n minus 1 equal 2 n minus 1. Now what do you think about minus 1 n minus 1? If n is odd, um, let's say 3, n equal 3, what do you get? 3 minus 1, minus 1 square, that is a positive value. If n is even, um, n equal even, so let's say 4, so minus 1, this is 4 minus 1 is 3, so this is a negative value. Now I can see, this is first term is positive, second term negative, this term positive, negative, positive, so this is positive. It means this value, this is positive, the value n of n should be a odd number, because positives are odd, 1, 3, 5, negatives are even, 2 and 4. Since this positive, then this should be a odd number. Then n is a odd number. If n is a odd number, this answer should be positive. Hence, I can write 1024 equal to n minus 1, or 2n minus 1 equal 1024. Then let's apply log. Uh, so n minus 1 times log 2 equal log 1024. Then n minus 1 equal log 1024 divided by log 2, and then n minus 1 to other side it is going to be positive 1, and you can get n value is in the book you can see 11. So now you know n is 11. Now we'll substitute here. This is going to be 11, and n equal now 11. So S11 equal 1024. This is a uh, negative times odd is negative. So that negative times this is positive. So 1 plus half a positive 11 divided by 1 plus 3 over 2. I can see the book answer is 683. 683. I'm going to do a bit of alteration to this sum. So for this direction, the r is minus half. So what is this term? What is this term? 1 before 1. So if we go to this direction, that is minus 2, because minus 122 times minus 2 to 256. 256 times minus 2, this one. So likewise 1 times minus 2 is minus 2. So this word minus 2. Now what will happen if we need to find the up to not minus 2 terms? So then the nth is going to be minus 2. So this is still the same. Now this will be minus 2. This is minus 2. Now what is the argument? Again 1024 minus 1 over n minus 1 equal minus 2 to the power n minus 1 equal minus 2. So 1024 times minus to the power n minus 1 equal minus 2 times 2 to the power n minus 1. Cross multiply. Now what is the argument? Here we know this is positive early one. Now this is, no, we know that this is negative. The negative ones are even ones. So n is even. If n is even, this value is going to be n minus. If n is even, n minus 1 is odd. If n is even, n minus 1 is odd. So then any odd value minus 1 to the power 11 or any odd value will give a negative answer. So this is going to be 1024 times negative minus 2 times 2n minus 1. Now this negative and this negative cancel out. Then 1024 equal 2 to the power n minus 1. Again it's become positive. Now you can apply the logarithms. Example 14. 1 plus 2 plus 4 plus 8 plus uh, so we need to find the term uh, when you find that term, let's say m, so that term value sm, the term of that term, partial sum of that term should exceed 200,000. So, so this is, let's say, TM term. So when you get the addition up to this term, it is exceed. So if you get the addition up to Tm minus term, so it will not exceed, it is less than 200,000. Actually this has to be equal, and then Tm plus 1 should be Sm definitely greater than 200,000. So we need to find this m term. So this is the inequality. Assume up to partial sum up to m term exceed 200,000 and an equal sign also. Uh, then Sm we know that a times what is a is 1 and r is 2 over 1 is 2. So I'm going to use this formula, r m minus 1 over r minus 1 greater than 200,000. So a is 1, r is 2 to the power m minus 1 over 2 minus 1 greater than 200,000. So this is going to be 2 to the power m minus 1 is greater than, this is 1, 200,000. Then this is 2 to the power m. Simply I can bring this 1 to other side. Um, 0, 1, and then logarithms. M log 2 equal log 200,001, then m equal or greater than log 1 over log 2. So m greater than or equal to, the book answer is 20.9. It means m is 21, because 20.9, 21 and 20. So 20 is definitely less than 200,000. 21 is definitely exceed the 200,000. What will happen in case if this falls onto 21? It means that 200,000 on the 200,000 on the sequence, and as a result it's not exceed, it is exactly equal. Then you have to go to 22. That's why I put an equal sign here. But if you can leave, usually the sum doesn't fix like that. So you can consider equal sign, greater than sign if you want.